Assalamualaikum and very good morning to the panel. I am HAZRAN bin HUSSAIN and I am TS Dr. BALJIT Singh AL BATHAL Singh. My name is Aiman Syakir bin Rozman. I am being supervised by Dr. Muhammad FAIZAL bin MOHAMAD. Today, I will present to you about my proposal final year project, which is Unsteady Renal Average Nervous Tone or URANS simulation of flow in a pipe. Enjoy the video. For the first part is introduction. Renal average nervous tone equation can be defined as time average equation of motion for fluid flow, while computational fluid dynamics, which is CFD, is employed in order to solve this equation. Continuous advance in computational flow have leading detailed description of flow behavior by enable CFD analysis of flow in a pipe. In this study, I use CFD software which is performed to simulate run approach. To be detailed, I simulate URANS approach to the flow of a pipe. Unsteady renal average nervous tone or URANS simulation is the better choice that allowing a better prediction of unsteady flow in a pipe. The model and provide more insight into physical properties of the flow and of the transport of a passive scalar is usually caused by unsteady phenomena. Next is problem statement. There are only several research that been made about the flow in a pipe. The most common approach that been applied to see the flow structure in a pipe is steady runs approach, but there are only several unsteady runs approach study regarding to the flow in a pipe. That's why I make a decision to make this study. The shape of the pipe is play an important role to the flow structure. The next part is objective. Objective that be targeted by me to be achieved is first, to investigate the effect of URANS approach to the multi-phase flow. Second is to investigate the flow structure based on the different shape of pipe. Then is literature review. There are several articles that been found regarding to URANS approach. First, in year 2030, authored by A. Carter and friend, the title is Improved Unsteady RANS Model Applied to Jet Transverse to a Pipe Flow. The improved URANS approach being applied cause the RANS turbulence model that using linear tubular viscosity model are well known to be disruptive and without constant unsteadiness can be damped. This model is allowed to unsteadiness development. The K epsilon and KL approach been implemented to the standard RANS and improve URANS of the flow. Both URANS K epsilon and KL model predict unsteady flow being used after considering to the unsteady mechanism and vortex shading that been adapted to the numerical scheme. The second article in 2018 by Adrian Didantis and FAIZAL, and the title is Assessment of Different URANS Model for the Prediction of the Unsteady Thermal Mixing in a T-junction. The prediction of unsteady flow is made by using different low Reynolds turbulent model, while the high Reynolds number been applied for calculation of T-junction thermal field in the well-resolved URANS configuration. The K epsilon approach been applied to this research. Thermal field is show a good representation of the is being provided by cubic K epsilon model, while the others turbulent model are still able to state thermal field qualitative estimate, but it will cause the shortcoming in unsteadiness flow field prediction and also affecting the thermal field that been obtained as well. The next article in 2020 by Wang Han Wang Shaoqilu Dongan. The title is Turbulent Flow of Water in 3x3 Road Bundle Numerical Result from URAN, URAN and LESS approach. For the RAN and URAN methodology, a time average pipe plus a fluctuation pipe is the composed variable. In RAN simulation, the reducer were set to 1 times 10 power of negative 5 to get the convergent solution fully, while in the simulation of URAN approach, the time taken was 5 times 10 power of negative 4 second, give a result of high current number of 0.6. The last article that been found by me is on 2020 by Amiri Mojtaba Mali Shatman Milad Stephen and Sagan F. The title is URANS simulation of a horizontal axis wind turbine under stall condition using the Reynolds stress turbulent model. Its aim to characterize the characteristic of turbulent flow on the wind turbine horizontal axis and evaluating some URANS turbulence model performance, especially RST model, in aerodynamic of wind turbine prediction in the stall condition. The simulation be done by using the star CCM plus commercial code by using NREL phase 6 wind turbine of an upwind configuration in 4 different speeds, which is 5, 10, 15 and 25 meters per second. After that is methodology. This is the flowchart that been used in my study. First is set the computational domain and boundary condition. Then construct the pipe shape by using CATIA software. Then setting the simulation setting, which is first provide the governing equation, set the turbulent model, and set the numerical detail by using or perform software. And lastly is test and analysis. Geometry domain. There are 3 shapes of pipe that being used in my research, which is 90 degrees pipe, 45 degree pipe, and 30 degree pipe. The inlet of the pipe has 2 because this study is regarding to the multi-phase flow. The flow that we use is water and oil. Simulation setting. First is governing equation. The governing equation that been used in this study is URAN approach equation. Below show the URAN approach equation. Next is turbulent model. In this study, the turbulent model that been used is standard K epsilon turbulent model. The below is the equation of standard K epsilon turbulent model. For expected result, I target to show the application of URAN equation and also to see the effect of velocity flow fluctuation due to the flow pattern. Last but not least is conclusion. A flow in the pipe is a common theme that been highlighted in the industrial sector. It is related to the company which have a piping system and it is very crucial to the oil and gas sector. There are various aspects must be considered in order to find or simulate the flow behavior in a pipe. In the future study, the computational fluid dynamic CFD flow analysis in the pipe will be conducted by using unsteady Reynolds average Navier-Stokes URAN approach in the OpenFOAM simulation. I think that's all from me. Thank you for you to spending your time for watch my video presentation for FYP1 proposal. If you have any question or inquiry, you can email it to my email that be stated in this slide. Once again, thank you and have a nice day.